So in this video, we are going to review over how to use Coulombs' law to solve various physics problems. Coulombs' law was developed by Charles Coulomb. He studied electrostatics and magnets, and he looked at the strengths of materials, and he was identifying forces and how they acted. Coulombs' law states that the force between 2-point charges is directly proportional to the product of their magnitude and inversely proportional to the square of the distance between them. Meaning that Coulombs' law shows that electrical forces have the following properties. It is along the line joining the two particles and inversely proportional to the square of the separation distance, represented r, between them. It is proportional to the product of the magnitude of the charges, Q1 and Q2, on the two particles, and it is attractive if the charges are of opposite signs, repulsive if the charges have the same sign. That one right there is super important for doing your problems. So mathematically speaking, Coulombs' law is represented by this equation right here, and you need to write it down. Now what we have here, this right here, sometimes it's written K sub C instead of K sub E. This is Coulombs' constant, and that's this right here, and you need to write that down. Okay, here we have our charges, and here we have our distance. Okay, a few things for you to go over. Again, that last statement that we just mentioned, that it's attractive if the charges are opposite, and it's repulsive if the charges are alike. It must be used in this particular equation, and the force is a vector quantity. So that Coulombs' law gives the force between the 2-point charges. The metric unit we have is Newton. Again, this is our Coulombs constant, and the force is along the lines connecting the charges. It's attractive if the charges are opposite. It's repulsive if the charges are alike. So while Coulombs' law is stated in terms of point charges, it's also valid for spherical symmetrical charge that is distributed, as long as the distance is measured from the center of the sphere. So here we have an example. We have two electrostatic charges of 60 and 50. They exert a repulsive charge on each other that's 175 newtons in air. We want to calculate the distance between the two charges. I've placed Coulombs' constant right here, and I placed our equation right here. You'll notice that our problem gave us Q1 and Q2, and our distance, in this case it's D, but it's here, it's R squared, is identified. Alright, now we have our K, we've got our two Q's, and then you'll notice that we have our force of 175 newtons. So what we've done right here is we've just rearranged the equation. You could put it in this as well, work it out, and because it's distance, our unit is in meters. Coulombs problems really don't get any more difficult than this right here.